My name's David Cramer. A lot of you know me from when I worked at Curse. I was the lead developer for 2 years. Curse is a massive website. It's one of the largest deployed Django websites on the internet. Our peak traffic while I was there was around 15 million pages a day, which is a lot for anyone who's not familiar with these numbers. And that's about 150 million hits, which includes static content, files, etc. Average traffic is a lot lower. It's like 120 million right now is their numbers. And that's, it's a gaming website, and every so often there were patches for these games. And whenever those came out, it's kind of like the Slashdot effect, except worse. We were Python, MySQL, Squid, Memcached, ModPython, Lite. We went through just about every software you could imagine, trying to figure out what is the right combination to work. Most of us, me especially, came from PHP. When I first started at Curse, it was a complete PHP shop. First task was to rewrite everything. It took us about 3 months to go from PHP to Django, and another 3 months to keep Django online. At the time when I left, we had 12 web servers. I believe 8 were for the Django scripts, and these were not all active all the time. 2 were for static, which is CSS, images, etc., JavaScript, and 2 were media, which was kind of our version of a large-scale CDN, videos, files, etc., downloads. We had 4 database servers. I believe 2 of them were running all the time, 1 master, 1 slave. Another 2 were sort of backup. 1 came online when things got heavy. And we had 2 Squid caches. There were also 2 hardware load balancers in front. Where I work now, I'm the director of technology at iBegin, and it's in the local industry. We have a different problem. We're not scaling to traffic or scaling to database. We have a massive data set with 100 million odd rows. I couldn't get the count because for some reason I can't access it from this internet. We use Python, PHP, MySQL, and we're using ModWSGI at iBegin. It's a small team of developers. I think there's 4 of us that work on the projects. We have, as I said, a complex database, and we have an even more complex system that partitions and synchronizes with multiple database instances across many servers. And unlike Curse, we're attempting to keep with trunk and not branch off into our own Django. So that's a bit about me. What we're going to talk about today is the database, which is, for me, the #1 priority in scaling all the time. As Guido brought up, a lot of things you can't do when you're trying to scale the database. We have the web server, which is Apache, Squid, etc., all of the services that serve your request. Caching, whether it's with Squid or with Memcached, any kind of object cache. Template rendering, and profiling that code. So let's first talk about what we're using to serve requests. We have our web server, which typically it's Apache or Lite HTTPD. Apache is going to be my choice. ModWSGI is far superior to anything else out there right now. It's really built for Python. We also used Lite at Curse for various things. We had kind of a complex setup, and I think I go into details a little bit later, so I'll save that. For caching, it's Memcached. There's nothing really else out there for the Linux environment. And there's nothing really for the Windows environment outside of .NET. For your database, there's a lot of choices. We use MySQL everywhere. I'm familiar with it. It's kind of one of those things, whatever works best for you. Postgre is also very popular. It's a great transactional database. MS SQL is very great. Oracle, if you have a lot of money, et cetera, et cetera. Page caching, which is when the browser sends a request to your Django scripts, on a high-scaling site, you need something in between to grab that request, typically for anonymous users, but even more so for registered users with a few tricks that I'll go into later. There's a few choices for this. Squid and Varnish are fairly popular. Squid is really the only thing I know of that's tested thoroughly on high-end sites. Nginx is, I haven't used it myself, but I'm told it works fairly well and can do just as much. And you have software load balancers, hardware load balancers. Nginx can do it, Perlball can do it. I think Pounce uses Perlball. We had hardware, which is a lot more expensive, but it's also a little bit more powerful, reliable, et cetera. So how we did it at Curse, we had primary web servers, which are the servers serving Django through mod Python. We were actually looking into mod WSGI right before I left, and it was showing, I want to say, a 40% improvement on memory and almost twice as many requests a second. So we served those through mod Python while I was there on the primary web servers. Our media servers, which serve downloads, files, videos, etc., we're using Django for tasks like resampling images, and we had this crazy CDN thing going on. And we used light HTTPD on there with fast CGI. And we actually originally started with that for our primary web servers as well, but there was a weak ref issue at the time. I don't remember what it was for, so we ended up switching off. And our static servers, which is our CSS, images, et cetera, we're also using Lighty, but it was a completely separate machine or instance. The load balancers, again, were hardware. And the way it worked is we had 2 load balancers in front, and then there were 2 squids behind those. Each load balancer, and again, let me start off by saying I'm not the server admin. I'm just the guy who writes all this stuff and gives them hell. But the 2 load balancers were in front, managing requests to the 2 squids, which then did more balancing to go back to the web servers. And at one point, I think even when I left, we were skipping the squids if the user was logged in because of the way our site was designed. And again, squids were load balancing to the web servers. So what we learned by doing all this, again, don't be afraid to experiment. There's a lot of choices for web servers, and we went through a lot of different ones of those choices. And as we did, you're not limited to a single server. Apache's very heavy, I'm sorry, and it uses a lot of memory and CPU, whereas Lighty and there's Tiny, which are a lot less intensive on your resources. So if you need static content or media, it's not a bad idea to use a different server for those and use different software to serve those. Mod WSGI is a huge step forward for mod Python. Like I said, we showed huge improvement. It's much easier to maintain it. You don't have to restart Apache to update your code. You simply, for example, touch your handler, and it'll just restart that instance. It's very, very nice for shared hosting environments as well. Serve static files with different software, especially if you're running on multiple servers. That can save you a lot. Sending proper headers, which I'm going to talk about a lot in this presentation. It's very key to caching, to cutting down your number of requests. Far futures headers is Steve from Yahoo, who I think now works at Google, was talking about in his lessons. It will really, really save you a lot of requests, which helps when you're dealing with thousands of requests a second. Use services like S3, Akamai, Limelight. These are all pseudo CDNs. S3 is great for larger files. It's not very fast on download speeds, so if you're doing videos, et cetera, you might want to look at something like the premium Akamai services. Otherwise, building your own CDN it's kind of one of those things. You don't want to reinvent the wheel. You don't have that amount of time, money, et cetera. So use existing services. So some of the software that's available, again, you have Apache, which comes in 3 flavors. It's WSGI, ModPy, and FastCGI. You have Lighty, just FastCGI. Someone can correct me if I'm wrong. Nginx, which I, again, haven't used personally, but it comes in FastCGI. You also have reverse proxies, which when I talk about those, I'm talking about page caching, which is Nginx, Squid, Varnish. There's quite a few choices for this, but I'm not sure how many of them work well. Static content, there's a number of things out there. Apache was really the last choice to use unless you're on a single server. There's Lighty, Tiny, Nginx, which is, I'm going to say Nginx is probably your best choice. From what I've seen, it scales the best. And software load balancers, again, Nginx, Pearlball. I'm sure there's more, but those are the popular ones. So we'll talk about the database, which is a very, very big thing when you're scaling. And the ORM specifically, because this is geared towards how to scale Django. It's not going to make your queries efficient. It will actually do the opposite. You have to be very careful what you do. When you're using SyncDB, it's going to create a bunch of useless indexes if you use foreign keys a lot. Drop them all, because for the most part, any DBA is going to tell you, you're not querying against a single index most of the time. The more indexes you have, the more it has to rebuild every time you add a row or do anything. So it's very important that you go through and you tweak the database to your specific needs. Select related can be good as well as bad. I'll go into that into a little bit more detail in a minute. And inherited ordering on the meta class, it's the ordering attribute, will get you. And I only list this because it actually got me recently, so it was fresh in my mind. What this does is it applies a default ordering to your query sets, and we had actually done it just for the administration purposes, so it'll order by name by default or something, which is nice in there, but outside of that, we're ordering by maybe like date changed or something else, which we've built indexes for. But what the inherited ordering does is it actually takes, anytime you do a query against that model itself, it's going to apply that ordering to it. So if you have a join across 3 tables and you have ordering set on all 3 of those, it should be adding ordering for all 3 tables within your order clause, which can be very heavy on large data sets. Hundreds of queries on a page is never a good thing. I say this because a couple years ago I saw a fairly mainstream site coming up with excuses for why they had 400 queries on one of their pages, and it doesn't matter why you, like, I think our limit, we said soft limit was 20 queries on even the most intensive pages, and we tried to stay away from joins as much as possible because scaling large data sets with joins gets to be a very big hassle. No one did not use the ORM. The ORM is great. It's the only reason we honestly use Django is for the ORM, and it makes life very, very easy. But at the same time, if you need to do a query that the ORM isn't going to let you do, don't find some way to make it do the query. Use a cursor or manually do it somehow. And these are, especially in MySQL, where you have a lot of shortcuts, on duplicate key update clauses, insert ignore clauses, etc., which can be a lot faster than doing like a get or create or something else. It's very important that you use the power of your database instead of relying on Django to do that, because Django is built as a generic framework. It's not built to make, or built against MySQL or built against Postgre or any of those. It's really built just to be generic. So joins, as Guido said, joins on large traffic websites can be very, very performance intensive. And especially when you're having large data sets, indexes become a big issue. And in Django, you have select related to do these joins, which it gets rid of your 400 queries, but at the same time, it can be very bad. And recently, the query set refactor landed in Django, which included the patch to select based on fields explicitly. So you can say, I only want to join on, in this example, category, or I only want to join on the user who created this, which is very good because it allows you a much better level of control over the whole situation. So in this example, we have a poll and a category, and the polls have a foreign key on category and user, and the category has a foreign key on user who created it. And so the typical example that I see people doing is just calling select related implicitly, which says join on every foreign key that you possibly can infinitely. And in this example, because there's 3 foreign keys and we're selecting, we want all the poll objects and there's 3 foreign keys. So we're selecting polls and then we're joining with user twice and category once. And the problem with this is in our template, all we want to do is show the poll with the category name next to it. So we don't really need those 2 instances of the user. While it might be nice to have in case maybe your designers want to show it, it's very bad to build things around that idea. So the good example is to just select related and specify the category field, which is very, very handy. And with the changes, it also lets you, for example, say you wanted to select a category and the category's user who created it. You could specify that in select related using the double underscore notation. And so we're going to go on past database and go on to template rendering. And Django is a sandbox template engine, which means it's kind of jailed. It's safe, like App Engine is safe from other app engines affecting it. The templates are safe from your template editors affecting your Python app or your server or anything like that. And sandbox engines are slower by design. That's just how they're built. There's no way around that. Keeping logic in views and template tags is very important. It makes it a lot easier to maintain, makes it a lot easier to cache. It's going to save you a lot of headaches down the road when you're looking for where this stray query came from or anything like that. There's a caching tag in Django inside of your templates. I would say it's useful. I've never used it personally. I, again, follow the logic of keeping it out of there. But it does allow you to speed up your templates a little bit. be aware of performance and loops. And this holds general outside of templates as well. There's the resolving of variables inside of nested loops is slow in Python. Group by, same thing. It's creating loops, and I believe it's called regroup in Django's templates. This is a very big issue in templates that can cause a lot of slowdowns, and we especially notice that on our templates. Loaded templates can be cached to avoid reads, and I'm not quite sure how well this works in Django, but you can, once a template's loaded into memory, typically in the engines they do some compilation, which will speed up rendering. And you can actually cache this with memcache or locmem or whatever you're using, just like you would anything else. And that can actually save quite a bit of time, as we were doing. It allows you to avoid the disk reads. It happens distributed if you're using memcached, and it's overall a huge benefit. And even more importantly, switching templates engine is easy. Like, I don't use Django personally on any of my sites. I use Jinja. It's the same syntax. It just is a little bit more powerful. But it's not necessarily going to give you any good gains. I mean, you may get 10 times the speed out of your template engine, but when it's only affecting 2 milliseconds of the time, it's not that big of a deal all the time. It's more about how you're using the templates. A quick chart of how fast the engines are. You have Genchi, which is, again, not very good. Django, which is fairly quick. Mako, which is not sandboxed. It does nothing. This is actually Jinja 2. It's the new version. And this is not sandboxed, I believe. And I just want to talk about this. The green, which you see is a benchmark test case. It's kind of, it's just a bunch of logic patterns inside the templates to test how fast it can handle all those. That's why you see such a huge difference in Mako and Jinja, whereas you don't in Django and Genchi. And the real world example is actually your typical template setup. It's inheriting from a base template. It's doing a loop. It's all of your typical things. And I actually have links to these that I can bring up at the end. So caching. There's two different styles of caching. You have the object cache, which is memcached, and you have the browser cache. The browser cache is Squid, Varnish, etc., and it's what comes in between your page. Django provides somewhat built-in support for both. You have cache engines for object caching, which it provides great support for it. It gives you support for disk caching, memcached, locmemcache, which I think is out of there as of 1.0, but you can still do it. And for browser caching, it provides several decorators for sending like no cache headers, for example. And overall, the response object is very easy to manipulate, and you can do middleware, etc., to handle it all. One of the biggest lessons we learned at Curse was invalidation is a huge headache, and we didn't plan it out very well. So we ran into the issue of we had expiration-based caches, but we would change something in one of those caches, and we would need it to change in all of the caches. Say it was a content-driven website, I'm sorry, and somebody posted something inappropriate. We would need to clear that from the entire website, which became an issue. And when I left, there was still no real solution for that. It was simply wiping caches by hand. Caching isn't a solution for slow loading pages or improper indexes. This is a very big thing. If your page is taking 3 seconds to render, caching that is not solving your problem. It's going to make it run fast for those 15 minutes where it's cached, but then again, you have, I don't actually know what they call this, some kind of train effect. When one user loads a page and it knows that it's expired, so it needs to recache it. Now you have, in the time it takes 3 seconds to recache that page, if you're getting 30 requests a second, you have 90 people attempting to cache that page. That's 90 people attempting to do a 3-second job, which this is going to result in server overload and can be a huge problem. Using a reverse proxy like Squid, etc., is very, very important when you're scaling high numbers. I think our Squid servers were doing around, it was either 2,000 or 4,000 requests a second when our Django servers were only doing 200. It's very, very important that you use the technology that's there. Caching with a plan. This is, again, like I said, without it, invalidation is a nightmare. Using proper headers is, again, very, very, very important. It will make it much easier to implement Squid or any similar solutions. create a plan for object cache expiration and validation. Expiration, I'm kind of against. I would prefer to invalidate when the data is changed. There's a few components that integrate well with some of the database servers, which will actually send signals when it needs to invalidate a cache, but I haven't found anything that works very well in Python. Expiration, you kind of need a default just in case somehow something bad has gotten cached and you don't have any invalidation plan for that because it shouldn't have happened. But you need to expire it eventually without having to manually go into it. Typically invalidation, and I'll go into this a little bit more, but when you're saving an object, set it in the cache if you're saving it somewhere. That's the best way we found to do it. It's the only way I've really found that works well. For typical web apps, you can serve the same page for both anonymous and registered users. And at Curse, we weren't doing this on curse.com. Some of our newer websites were. And this is a fairly old style, but it's very good. And why I say typical is because it requires JavaScript. An example is most pages. The reason you wouldn't cache the page both for the user and the anonymous user is because you have to show you were logged in as David or something similar. Using JavaScript, you can cache that page for every single user, but you can send another recall for another call for a JavaScript page, which is just going to write in that user's information. You are logged in as whatever, or it'll say you need to register or something similar. And that page, again, you can use headers on it, which is going to cut down the number of requests. It's going to make it a lot smoother for everything. Contain commonly used query sets and managers. This is very, very helpful, and not necessarily managers, but your objects on a model is a manager. And if you're doing something like getting the top or the 10 latest blog posts on your blog, and you do that all over, and you want to cache that, having to go into each view where you're doing that and your RSS feed where you're doing that it's a mess. And then invalidation is even more of a mess when you have to go find all the keys that you're using. So doing these inside of a manager-like object inside of your class makes it very easy. You can do something like get latest or something, whatever you want to call it. As long as it's contained and it's reused over and over and it follows a dry principle, it's going to make things a lot less of a headache when you have to go to your invalidation. And when we talk about having a plan, if you expect your website to scale, it's good to build in caching from the beginning. Even if it's not enabled, you can use the dummy cache engine. If you're using the cache calls from the beginning and you're building it for invalidation, it's going to save you a lot of time in the future when you need to go back and this page all of a sudden needs to be able to handle 100 times the amount of traffic. So an example of where caching is good. Context processors are called almost every single page. And I think in Django they can even be called multiple times on a page load. So it makes sense if you're doing something like hitting the database or something that's resource intensive to cache it inside of there. So in this example, we have a context processor and we have my model, which is, who knows what it is, but say it's a list of sites. And we want all of the sites because we use it in a sidebar on every single page. So we want that in all of our templates. So we actually cache that query set, which is all of the objects, on every single page load. Or we cache it so it doesn't have to execute on every single page load. And then to invalidate it on the save method, we reset the cache. Instead of just deleting the cache, which I've seen is pretty common, we actually reset the cache so it doesn't have to do another call to the database afterwards. And what's good about this is you don't have that train effect, so you don't have to set locking keys or timeouts. You just set it instantly, which means it's updated instantly. It's also a neat thing you can do when you're caching an entire query set, which you don't want to do this on large amounts. But for example, in my model, you could do a custom manager or just custom methods, which will pull from that cache. And content types, I think sites, a bunch of the contrib apps do something similar. They use local memory caches. But it makes it so whenever you query for something like, that's out of my model, it's not even going to have to hit the database if you're querying based on ID or something else that's very common. Profiling code. And this was very new to me at Curse and a lot of us. Finding the bottleneck took a lot of time. I would say most of the time, 95% of it was finding where the problem was and finding what is slow. There's tools that exist, and we were new to Python, so we didn't know anything about these tools. We were using PDB inline, and we had some code to hijack an Apache instance and see what was going on. It was a big mess, basically. But there are tools that exist to help this. CProfile module is one of them. There's good documentation on how to use that on the Python site. The Python debugger is another. I'm sure somebody else can fill me in on more. There's a great example I pulled off of Django snippets of using CProfile in a Django template, which is actually very nice. I modified it a little bit, and it's kind of shrunk down to fit into the slide. But what this does is it's a middleware that you throw on your page, and if debug's enabled and you are able to access whatever via the internal IPs setting, and you put $prof at the end of your request, it's going to spit out a page that will show you all of the it shows you all of the information about what it took to render your page. And for those of you who aren't familiar, it's quite a lot of information here. The first column here is the number of calls, and you can see below where it separates. You have let's see, what is that? Python.py. You have 1331/1. The first number is how many actual times that was called, and the second is it's when you're looping through recursion, basically. The first number is how many times it was executed during loops, etc. And the second number is how many times it was explicitly called. The TOT time is total time. That's the total time it took to execute all of those calls. Per call is the total time per call, so it's total time divided by n calls. Cumulative time is, I actually don't quite remember, actually. This is embarrassing. And per call is cumulative time divided by number of calls, but somebody else can include subcalls. There you go. And then you have the file name and line number, which helps you break it down. And this is from a Jinja-based website, so you have all these lexers and whatnot, which is the template engine there. And this is running on run server, which explains the time. And database queries is another thing you want to profile, which isn't included in CProfile, obviously. And so I just, based on the CProfile middleware, I threw one up which does something similar, and you just put dbprof at the end of your URL. And it'll spit out a similar page, which gives you all of the queries executed. And this is where I'm talking about inefficiency in queries. This is one of the random side projects I have. And as you can see, Django selects every field in a query. And you can get around that by using values or values dict, which works in some cases, but not in all, because sometimes you want a model instance. And I believe there's a patch coming that's going to allow you to specify what fields you want at the time and then just defer to other fields later. But what you have here is the total time, the number of queries, how much time it took for each query, and then the entire query. And I'll make both of these available on my blog later tonight. And that was actually probably way too fast. But database efficiency is the typical problem. It's always been our problem at Curse. That was why we had 4 database servers, just in case. And caching plays very, very big into that. Develop and deploy the caching plan early on. It's very big that you get the invalidation right, and I still don't have a good solution for it. I started on a project which would do object-level caching, which is kind of a neat concept. It's where, say you have the blog.objects.all, and what this would do is it would store a list of all the IDs that were found in that query set. And then you do another call to memcached, which is a bulk get, which would get 10 keys out of that. So you'd have 1 row per object, and then invalidation is as easy as deleting one of those keys or updating one of those keys, which is very nice, but making that perform well, I've yet to do. So use profiling tools to find your problems. It doesn't always help, but it might get you on the right track. For example, there's a patch in Django, ticket number 17, and I have to bring this up, you know. And what this does is it shares objects in memory. So if you have article ID 1 over here and you have article ID 1 here, it's actually the same object, which Django doesn't do by default. And at Curse, we use this patch because it saved us a lot of memory and a lot of CPU. But we ran into issues, for example, where pulling data from memcached would skip the serializer. And well, that's a bad thing because we wanted even the data from Memcache to use the same instances as the data everywhere else, so it's always the same, and when we update it, it's updated everywhere. So when we changed that, we ran into the issue of now that we've got the same instance everywhere no matter what, we're pulling in old data from Memcache, and somewhere else we want the new data to update it in the database. So we ran into this big issue of how do we handle that, and we never really found a good solution. We ended up timestamping data in the Memcache key and comparing it with the data in the local cache key, and it was a big mess. So I think we spent 6 hours trying to debug how user was not getting changed in our code, and it was one line that we had to fix. And so again, like I said, finding the bottlenecks in your code can be very, very time consuming. And then find someone who knows more than me about software, because I have done very little configuration. I didn't do any of it at Curse because I was very new to it at the time. I do all of it at iBegin, but again, as I said, we are a much more low traffic site where we scale on the database level versus the actual traffic level. So Squid, et cetera, there may be better ways to do it. There may be better solutions. But these are what we did. These are our mistakes, if I will. And somebody else will be able to tell you more in that regards.